Hello people, welcome to Gurukula. I'm Jai. So today in this video we are going to see about the flow control, which is a main functionality of a data link layer. So whereas in our previous videos of the communication networks we might have studied the various functionalities of data link layer, and especially in the very previous video we might have seen the concepts of framing. So what are all the types of framing and what are all the problems that is existing in framing, and how to overcome all those problems. All these kinds of stuffs were discussed in the previous video. So today we will see the another functionality of data link layer, so that is flow control. So without any further delay, let's get into the topic. So as I said in the previous video, we might have discussed what framing is. In this framing topic we have discussed what's framing, what are all the types of framing, and what are all the various methods that is used for identifying the boundaries. So if you have not yet watched my previous video on framing, I will leave the link on the top right corner on the I button and as well as in the description section. So please do refer the links and then please do watch the previous videos on framing. So today our point of discussion will be the flow control. So in flow control we are going to see two aspects. So one is what is flow control, and then what are all the types of flow control that is available in the data link layer. So this is what will be the point of discussion of today's particular video. So before directly getting into what exactly flow control is, let us understand why do we need flow control with an real-time example. So let us assume that I wanted to travel from my home to office, and it's quite obvious that I am going to travel by road. So if I travel by road, there will be several routes that connects my home and then the office. So I can choose any route depending upon several parameters such as the traffic condition, the road condition, and then the climatic situations. So like this, there are several other parameters which will help me, or I will consider several parameters to choose which road I will have to select to travel from my home to office. And while traveling from home to office, this particular roads is an public property, which is not private for me, which is an public property where many of the users will also travel in this particular road. So when there are multiple number of people accessing a particular common resource such as roads like this, we cannot travel in our own way or in our own fashions. So we have traffic regulatory norms and we have traffic lights here and there installed in order to regulate the flow of traffic from one point to another point. Similarly, if we do not follow this particular traffic lights, then we may end up in two different situations. Firstly, we may experience an traffic congestion, which means a traffic jam, so that we may experience a deadlock. Or in the second cases, we may experience an accident, whereas two people will collide each other, they may met with an accident. So in order to avoid these two problems, what we do is we have traffic lights installed on our roads, which actually regulates the flow of information from one point to another point, actually the vehicles as far as our example is concerned. The same scenario happens in the network as well. So let us consider the home is my source and then the office is my destination. So similarly, when two nodes on network has to communicate, definitely it should be connected by many routes. So a source and destination will have several routes through which the packets from source node will reach the destination node. And then the routes will be selected based on different parameters, and which is not our point of discussion now, which will be take it in the further classes. So now each and every packet that is originating from the source will take different routes and then it will finally reach the destination over here. So as like in real time situations, the traffic that is entering the network should also have certain regulations to control the flow of packets in the network. So this is where exactly the flow control will help us. If there is no flow control mechanism deployed in a particular network, then even there we may experience a congestion, whereas all the packets will get congested and the network will go down. and in the other cases there is a lots of chances that two packets will collide each other and there may be a high chances of data loss. So in order to overcome these two problems, we should definitely incorporate the flow control mechanism. And not only this, we also have another good reason to implement the flow control mechanism, which is, let us consider that this is the scenario of one case, and let us assume that this is the scenario for the second case. Now the viewers are expected to assume that whereas the left image can be assumed to be a transmitter and then the right image can be assumed as a receiver, and you can clearly observe that the left image is processing the information at a faster rate and the right side image is processing the information very slowly. So this actually depicts that each and every devices that is connected on the internet will operate at different speeds. Say for an example, if the transmitter is operating at a higher data rate, it will keep on flushing the data into the network, and then the receiver is not capable of receiving the information at the speed at which the transmitter transmits the data, then obviously the buffer at the receiver side will get overflowed at a shorter time. So this will create a network congestion or the loss of packets. So this is also another good reason for us to have or to implement a flow control mechanism on the network. So this is the actual scenario that necessitates the flow control is to be implemented in the network. So with these two examples, now it might be very clear to the viewers that what is the need for flow control and what should we do in order to control the flow of packets from source node to the destination node. So with this understanding level, let's get into the technical aspect of the flow control. So now to be discussed, there are types of flow control mechanisms that we have. Majorly there are 4 protocols which is implemented to deal with the flow of packets on the network. The first two are the simple protocol and then the stop and wait protocol, and the later two parts are go back n protocol and then the selective repeat protocol. So today in this video we will be discussing only the first two protocols, and then in the later videos we will be discussing the second two protocols. And for your information at this particular point, the later two, that is your go back n protocol and selective repeat protocol, can be called as a sliding window protocols. But now we will not be discussing these two protocols, but we will be discussing only the simple protocol and as well as the stop and wait protocol. So we will get on to the simple protocol first. So in simple protocol, so our first protocol is what we call it as the simple protocol, where neither flow nor error control is implemented in this simple protocol. This simple protocol will just assume that the transmitter and then the receiver is operating at the same speed, and also whenever the transmitter transmits the data, the receiver is going to receive it and it is going to be processed at the same time. That is what the main assumption that is made in the simple protocol. And this is how the flow control of the simple protocol can be depicted. So you will have a source node on the left hand side and you have a receiving node on the right hand side. So whereas a packet which is originated from the sending node will be immediately transmitted to the receiving node, and we are assuming that the receiving node is actually processing the data as and when it is received at the receiving node. But sadly, this will not be the practical situation that we will experience in the real time situations. So that is why we go for the another protocol, that is what we call it as stop and wait protocol. So in this protocol, the sender will be sending one frame at a time, and then it will wait for an acknowledgement from the receiver before sending the next one. You could represent this particular figure over here. So what we can do is we will try to study the functionality of stop and wait protocol in 3 different cases. The case 1, what happens if the frame transmission is successful, and secondly, what if the frame is lost or damaged, and what if the acknowledgement is lost or damaged. So we will see all these cases one by one. So first case, what happens if there is a successful transmission of the frame. So if the frame is received successfully at the receiver, an acknowledgement will be sent to the transmitter by the receiver. As you could see in the figure, there is an origination of packet. Once the packet is originated, the transmitter will fire a timer. for a predefined amount of time. This will be in milliseconds. So once this timer have been fired, the frame will be sent to the receiver side, and whenever the receiver receives the packet, the receiver will send an acknowledgement, and remember, this acknowledgement should reach the transmitting node before this timer gets expires. Only then my transmitting node will start sending the next frame. So this is what will happen if there is a successful transmission of frame from source node to the destination node. Now let us see what happens if the frame is lost or it is damaged during the transmission. So what happens during this particular case is, let us assume that the packet is generated, a timer is fired, and then the frame is sent, but due to one or other reasons the frame is lost somewhere in the network over here. So what will happen, you will have this timer to be expired over here, the timer will get expired here, and since the receiver did not receive any frame, there will not be any acknowledgement initiated from the receiver side. So now looking from the transmitter side, there will not be any acknowledgement before this timer runs out, so that the transmitting node will assume that the frame is lost somewhere, and then it will reinitiate the timer, and then it will resend the frame once again to the transmitter side. And now you could clearly see that the frame has been received from the receiver side, and the receiver has also sent the acknowledgement which is received at the transmitter side before the timer gets expired. So this is what will be the case for when a frame is lost, and as well as if the received frame is damaged at the receiver side, this frame will be discarded at the receiver side, and there will not be any acknowledgement sent to the transmitter side as well. So this is what our second case is. Now let us see, there is a possibility of this acknowledgement frame to be get lost as well. So that is what will be our third case. Now in the third case, as you could see in the figure, the first time the frame is generated, the timer is fired, and the frame is also sent. The receiver also receives the packet, and the receiver has responded with an acknowledgement, but this time the acknowledgement is lost somewhere on the network. So in this particular case, the transmitter will not receive any acknowledgement up to the timer runs out, so that the transmitter will misinterpret that the receiver has not received any frame, so that it will reinitiate the process again, so that the frame will be resent again. So this is quite a drawback. This particular scenario may lie in a little bit of drawback side. Why? Because there at the receiver side, the frame sent in the first attempt is itself received successfully, but due to the loss of acknowledgement, the transmitter is again retransmitting the frames over here, so that there is a duplication of packets occurring at the receiver side, which is actually waste of energy and waste of bandwidth, waste of power and everything. So this is a main drawback of stop and wait protocol. So in order to overcome all these types of drawbacks, we go for the other two types of protocols, and also this type of protocol we will be sending only one frame at a time, and will be waiting for an acknowledgement, which is also very time consuming. So that we have other two sets of protocol where we have sliding window protocols, whereas as per the concepts of sliding window protocol, we will send multiple frames at a time, and then only one acknowledgement will be sent from the receiver by acknowledging all the set of frames, so that the acknowledgement is very faster, so that the transmission will also happen at a very faster rate. So this is a key difference between the stop and wait protocol and then the sliding window protocols. So that's the topic that we wanted to discuss today in this particular video. In order to sum up, we have just introduced what exactly the flow control is, and we can relate the flow control concept to the traffic control signals that is available on our roads, and under which we have seen two types of protocols. One is simple protocol, in which we have assumed that the receiver is going to process the frames as and when it is transmitted from the transmitter side. And in the later case, we have seen another type of protocol, that is what we call it as stop and wait protocol. And whereas in stop and wait protocol, transmitter will be sending one frame, and then it will be waiting for an acknowledgement from the receiver side. So that is what the entire principle of the stop and wait protocol. So I'm going to stop this video over here, and I'm going to see you in the next video. Until then, it's bye from Jay, and then happy learning.